In this video, we're going to talk about how you treat wastewater and what wastewater is. So wastewater comes from homes, industry, and agriculture. And all of that must be released into the environment. So the wastewater that goes through our homes, for example, when we go to the toilet or when we wash up, has to go into the environment. Industry, large-scale washing, large-scale cleaning, for example, has to go into the environment. Agriculture, fertilizers and such forth, has to go into the environment. Examples of pollutants, for example, as I said, sewage, which contains organic matter, excrement and harmful bacteria, your toilet, okay? And they can also include agriculture and the excrement and things like that from agriculture. Now, industrial waste, harmful chemicals, toxic metal compounds that might go into your wastewater, agricultural waste, fertilizers and pesticides. Now, fertilizers might be good for you to go onto your biology course and look up eutrophication. So eutrophication is a very dangerous thing when it comes to fertilizers being too concentrated and leaching off farmland. And that can disrupt sensitive ecosystems. It's not in the chemistry course, so I'll let you go and look at biology, but it's an important point. So we're now going to go through the 4 stages of sewage treatment, and it's much similar to making potable water in some ways. Okay, you've got to get rid of all of this mess that's in it, organic matter, stones, sticks, okay, and you do that through a filter, first of all. So that filter's coming down there, okay, and then that filters out all the large parts. Now we've just done sticks and stones, but remember this can be organic matter of any type. So this might be, for example, excrement coming from toilets, and feces and such and so forth, and industrial waste. So that's called screening and grit removal, so it's highlighted because you need to know it. Next part is sedimentation to produce the sewage sludge and the effluent. So the sewage sludge and the effluent, I'm going to talk through this in a little bit more detail and show you here. So sedimentation means falling down to the bottom. So if you look right here, let's look at it falling down to the bottom. Okay, so that falls down to the bottom, sewage sludge is at the bottom, effluent sits upon the top. Now we're going to go through 2 types of treatment here, and there's aerobic and anaerobic treatment. So anaerobic means without oxygen, aerobic means with oxygen, and that's from your biology course, but aerobic with oxygen, anaerobic without. Makes sense, the effluent is on the top, so it has access to all of the gas above, which means aerobic treatment would make sense on the effluent to make it safe. The sewage at the bottom has no access to oxygen, particularly because it's right at the bottom. Okay, and therefore makes complete sense that it's anaerobic bacteria that work on there. If you simplify that and just put it in the 2 points you need for the exam, there's anaerobic digestion of the sewage, remember that's at the bottom, and then aerobic treatment of the effluent using bacteria in both cases. But in terms of the exam answer, and the 4 parts you need to remove, it'll come in green here. This is what you need to know and write.